Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And take that, it's challenging. Yeah, okay. Today's puzzle is called Hatchet Man by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is in this case is a box. And within a cage, digits must not repeat and they sum to the small number in the top left corner of the cage. So for example, these 5 digits must add up to 22, these 3 must add up to 9, and these 2 must add up to 15, etc., etc. So for example, if you had a 4 here, this would have to be an 8 because these 2 digits add up to 12. And again, you cannot have repeats within these killer cages. So this is just a normal killer cage Sudoku, and it's called Hatchet Man, I guess, because of the drawing. I'm not sure if this is the face or if it's a hatchet or whatever. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So here we have 3 digits adding up to 9. So these must be the digits 1 through 6, 1 through 6, 1 through 6 here, and 1 through 6 here. That's interesting. That means this looks like it's a Phistomefel ring solve, probably. That means in this Phistomefel ring, what are the sums possible? You have 9 4 times, which is 36. And then you could have 8 and 9 here and 8 and 9 here. So that adds up to... So... That means it's what? 36 plus 34, right? 17 times 2 is 70. So the ring can add up to at most 70. I get it. Okay. The 13 and the 12 and the 15, those can only add up to... Those can only have the digits. For 12, it's 3, 9, 4, 8, and 5, 7. For 13, it's 4, 9, 5, 8, and 6, 7. And for 15, it's 6, 9, and 7, 8. Well, we know, so that means each of those must have a digit from 7, 8, or 9, right? 12, which is the smallest one of them, has to be 3, 9, 4, 8, or 5, 7. So that means there are 4 digits in each, because of the Phistomefel ring theory. We know this Phistomefel ring must be exactly the same digits as the 4 corner cells. Well, none of the 9 cages can ever be greater than, can ever have a digit greater than 6. And we know there has to be in this 12 cage, the 13 cages, and the 15 cages, at least 1 digit, which is from 7 through 9. Well, because of that, you know where can in the Phistomefel ring, where can you have the digit 7 through 9? It's only in these 4 spots. And since it's only those 4 spots, you can have at most 4 digits in the Phistomefel ring from 7 through 9. And we already have that taken care of by the 4 cages in each of the 2x2 corners there, right? 12 needs a digit from 7 through 9. 13 needs a digit from 7 through 9. So does this 13, and so does this 15. So therefore, this can't be 2 unique digits from 7 through 9 here, which it would be if it's 7 and 8, because that would require 5 unique digits from 7 through 9 in the corners, and we don't have that available in Phistomefel's ring. So this must be a 6-9 pair here. That means we are guaranteed to have a 9 in one of these spaces. We are guaranteed to have a 6 in one of these. That means these digits have to be 1 through 6. Same with these. These digits are 1 through 6. These digits are 1 through 6. And these, well, okay, not this one. These digits are 1 through 6, and these digits here are 1 through 6, right? Because we already have accounted for all these digits here have to have a 7, 8, or 9 in them. We know 9 is one of these. We know there's a 9. The question is, can we have more? So this can't be 6. These can't be 6 because of the 6-9 pair in the box. This is, again, 3, 9, and this can't be 9 here, so this can't be 3, 4, 8, or 5, 7. This is 4, 9, 5, 8, or 6, 7. Okay, so one of these digits, so, okay. This pair of 13 cannot match this pair of 13, right? If this is 6, 7, this can't be 6, 7. But you could have opposite sides. We do know these digits here add up to 34. So these 3 digits add up to 45 minus 34, which is 11. Right? 45 is all the digits in a row or in a column or in a box adding up. So to add up to 11, you can never have a 9, right? 9 plus, it would have to be 1 and 1, but that's not unique, so that doesn't work. So this can't be 9, this can't be 4. Does that tell us anything else? Maybe? We know 9 cannot be in the middle. Hmm. Can you have 27 without a 9? For 5 digits, yeah, that works fine. 1, 5, 6, 7, 8 is fine. Okay, so what are the 3 digits possible to add up to 11? We could have 1, 2, 8. All of them work. 1, 6 to 4 also works. Oof. Okay, so that's pretty broad. Hmm. It's not that restrictive. What about the sum of these digits? Does that help us any? Not particularly. Uh, what are these totals? This is 16 plus 22 plus 18. Does that tell us anything? Not particularly. There's only one other 9. We know that at most in these cages. Hmm. Oh, that's interesting. There's only, in these cages, there's only one digit from 4, 5, and 6 in each of those cages. Right? For each of those. So that means there's 4 total digits from 4, 5, and 6 from each of those cages. Right? Because you can either have 1, 2, 6, 1, 3, 5, or 2, 3, 4. You have 2 digits from 1, 2, and 3 guaranteed in each of those cages. That's not that helpful. We do know there's one digit here. No, that's not helpful. We know one of these digits is from 4, 5, or 6. One of these digits is from 4, 5, or 6. But this could be from 3, 4, or 5. Yeah, that doesn't help. Obviously, we know one of these is 1, 2, and 6. But we're not guaranteed anything else in these cells here, right? Because the problem is that this could be 3 and 9, so there could be a 4, 5, and 6 in one of these cages here. That was actually very interesting, though. We are guaranteed 4 digits from 4, 5, and 6 in these cages at period. So, and we have what? 8 digits from 1, 2, and 3. Oh, that's kind of interesting. Bingo. Okay. So, in these cages, we have 8 digits from 1, 2, and 3, and 4 digits from 4, 5, and 6, right? To add up to 9. In row 8, you can only have 3 digits from 1, 2, and 3, right? There has to be a fourth one that is from 4, 5, and 6. So because of that, you know you can't have 4, 5, or 6. I'm sorry, you have to have one digit from 4, 5, or 6 in that's not in these cages. Because of that, you know there's a 4, 5, you know there's a 6 here. You know there's a 4, 5, 6 here. You know there's a 4, 5, 6 here. You also know there's a 4, 5, 6 in one of these cells here. That makes 4, 4, 5, and 6 we've accounted for. Therefore, this cannot be 4, 5, or 6 here, which forces this to be a 3 and a 9. That means this can't be 3 here. We have a 4, again, a 4, 5, 6. This has to be a 1, 2, 3 triplet here with a 4, 5, and 6. Because if it's not 3, that means you have 2 digits in row 8 from 4, 5, and 6. This is 1 from 4, 5, and 6. 2, 3, and then you'd have 2 here, so that would be 5 digits from 4, 5, and 6, which is not allowed because it must match the Phistomefel ring. So this has to be a 3 here, guaranteed. So this can't be 3 here. This can't be 3 here. This 9 means we have 2 9s here. So there's a 9 in one of these cells and a 9 in one of these cells. This cannot be 4 and 9. This can no longer be 4 or 9 because that would mean there are 3 9s in the corner cells, which would be not possible to match in the Phistomefil's ring. Because you can only have 2 9s possible there. Therefore, we have a digit from 4, 5, and 6 here. This must be 1, 2, and 3. That eliminates 1, 2, and 3 in the rest of this row, so it's 4 through 9. This can't be 9, though. This can't be 9. Where is the 9 in column 7? Can't be here because of the 6, 9 pair in the column. Can't be here because of the, or in the box, sorry. It can't be 9 here because of the 9 in the box. Can't be either of these because of the killer cages, so this must be a 9, which means this cannot be 9. So we need one digit that's 7 or 8 here, and one digit that's 7 or 8 here. So one of these is a 9, we know for certain, so this can't be 9. We have 2 3s in, at least, in these 9 cages. We know one of these cages contains a 5 or 6. This cage contains a 5 or 6 also. Because it can't be both. So if this is 5, if say we don't have a 6 here. Say we have a 5, 8. That means this can never be a 5, 8 pair. It can't be 4, 9. So it has to be 6, 7. So one of these is 5 and 8. The other one is 6 and 7. Well, we know we have 2 3s guaranteed in these cages. So if we also know, though, there are 2 guaranteed 6s in these cages. One of them is one of these 2. The other one is here, right? Because again, if this is 5 and 8, this can't be 5 or 8, so it's 6 or 7. And it can't be 4 and 9 because we can only have space for 2 9s in the Phistomefel ring. And that must match the corner cells. So we know this cannot be 4 or 5. This cannot be 4, 5, or 6. And we also know, because we have our other 4, 5, 6 here, we also know we have 2 6s in the Phistomefel rings, which means that must be 1, 2, 6 in 2 of those cages. Well, we also have 2 3s, because to match this, this 3 and this 3, we need a 3 in this Phistomefel ring. But since we have 2 6s, we have to have 2 3s, but the 3s can't go in the cages with the 6s. Therefore, we know these cannot be 3. Because if these were 3, the problem is we'd have 3 3s in these cages, or in this Phistomefel ring, which would specifically be in these cages, and we know 2 of those cages must be a 1 2 6 triplet. So we don't have access to 3 3s. Therefore, these can't be 3, these can't be 4 5 or 6, so this is a 1 2 pair here. This is a 1 2 pair, which eliminates 1 and 2 in the rest of the column, respectively. So this is 1 or 2, this is 1 or 2, this is 1 or 2, which eliminates 1 and 2 here, 1 and 2 here. So this cannot be 6 here, because if this is 6 here, the problem is that, so this cannot be 6 again. It has to be 1 3 5 or 2 3 4, because this can't be 1 or 2, because of the 1 2 pair in the box. We need a 1 2 6 somewhere, though. So that means we have access. So for the 1 2 3s, we have 3 that are from 1 2 and 3. Sorry. We have 3 that are from 1 and 2 each, and 1 and 2 3s, right? So for the 1 2 3s in the Phistomefel ring, again, we have 3 for 1 2, right? Because we have 1 2 in this row, in these 4 cells. And these have to be a 1 2 pair. And because you can't have 3 available here, right? And it can't be 4 5 and 6, and it can't be 7 8 or 9 to match the Phistomefel ring. So this must be a 1 2 pair guaranteed. We have to have 1 2 here in this row. That means it's a guaranteed 3 for each of the digits 1 and 2. That means there are 2 3s. So the 3, again, we have 2 cages, which are 1, 2, and 6. That counts for 2 1s and 2s. We know there's a 5 here, so there's a 1 3 5. That means we must have a 2 3 4 in the last cage, because we can only have access to 3 1s. So this has to be a 1, because we know none of these can contain a 4. We know the 4 has to be one of these 4 digits here. And this can no longer be 5 or 6, because we have the 5 and a 6 is accounted for the Phistomefel ring correlating to the corner cells, right? This is a 5 or 6, this is 6, this is 5 or 6, but we don't have a 4 yet. So this cannot be 5 or 6, this has to be a 4, which means this can't be 4, this is 3. This can't be 3 or 4 anymore. These have to be a 1 2 pair. So 4 cannot be any of these cells. This is a 4 here. This cannot have a 9. 3 digits adding up to 18, though. This can't be 4. These digits, again, these 3 digits add up to 11. So it cannot be 1, 3, and 8, because that's 12. It could be 1, 3, 7, adding up to 11, or 2, 3, 6. So this has to be a 6, 7 pair, which means this can't be 6 or 7. This has to be a 5, 8 pair here. That eliminates 5 from being here. This can't be 6 because of the 6, 7 pair. This can't be 6 or 7. The rest of box 1 is 3, 4, 6, 7, 9. Okay, this has to contain a 1 or 2. Interesting. This can't be 3. The rest of box 3 has to be 3, 4, 5, 7, 8. Okay. This 18 cage cannot contain 1, 2, 4, 5, 1, 2, 4, or 9. So this can't be 4. The rest of column 8 is 3, 5, 6, 7, 8. Okay, what adds up to 18 here? 5, 6, 7. 3, 7, and 8. But this can't be 3 again because of the 3 in the box. So it's either 3, 7, 8 or 5, 6, 7, I think. Right? Are those the only possibilities? So you have 8, 7, 3. You can't get 8, 6. You can't get 8, 5. 7 could only be 6, 5. Yes, so this has to be 7 either way. That means this cannot be 7 here. So we know this is either a 3-8 pair adding up to 11. Because this is 18, right? So 7's here. That means this is 3-8. Or this is 3-8. Or it's 5-6. So this can't be 5 here. This is 11 no matter what. So this must add up to 11 here. It cannot be 1, 2, and 8. So this can't be an 8 here. It could be 1, 3, 7. So anything with 3 or 7 can be here. This can never be 1, 6, 9. It could be 1, 7, 8 technically, right? This is anything from 4 through 9 also. But we also have 4 through 9 here, right? This can't be 9. Okay. To add up to 19, you could have 4, 6, and 9. Still kind of broad. This can't be 6 or 7 because of the 6 or 7 in the box. So this adds up to 11. We know that for certain. Okay, so this adds up to 11. This is 16. So 11 plus 16 is 27. Right? We know that's guaranteed because we know this is 18. We know this is the leftovers. Cannot be 1 or 2, 4 or 9. This has to be the leftovers, which means it must add up to 11. So since this is 11, this is 8. This is 18. This must be the other 2 digits, which cannot be 7. So it's 11. That makes this 11 total. Excuse me. 11 total. This is 16. So these add up to 27. That means this adds up to 28 or 29. If this adds up to 28 or 29, these 2 digits must add up to 45 minus 28 or 29, which is 16 or 17. Can't be 17, so it must be... can't be 16, so it must be 17. So this is 8 and 9, which makes this 6 and 5. Again, this is 11. This is 11 here. This is 16. So you have to have a 1 here. So this must be 1. This has to be 2, which makes this 1. That makes this 2. This is 2, 3, and 6, adding up to 11 here. That makes this a 7. This can't be 7. It can't be 6 here. So it cannot be 1, 6, 8. It's 1, 5, and 9. And therefore, this is 9, and this is 5. That eliminates 5, 6, and 9 here. That makes this a 4, 7, 8 triplet. This is also 4, 7, or 8. This is 7 or 8. 5 cannot be either of these. This 4, 7, 8 triplet in box 4 eliminates 4, 7, and 8 in the rest of the box. So this can't be 4 here. This is 2. This is either... okay, so this adds up to 11. That means these two digits must add up to 9, right? Yeah, 11 minus 2 is 9. So it cannot be 7. It's either 3, 6, or it's 4, 5. Wait, that's a problem. Oh, it can't be 3, 6. If it's 3, 6, that would eliminate both 3, 8, and 5, 6 here, which is not possible. This can't be 5 because of the 5 here. Therefore, this must be a 4, 5 pair, which eliminates 4, 5 in the rest of the cage. So this can't be 5 and 6. This is a 3, 8 pair, which means this can't be 3 and 8. This is a 5, 6, 7 triplet. This 4, 5 eliminates 4 and 9 here. This has to be 3, 6, and 7, adding up to 16. 9 is here, so this can't be 9, and this can't be 9, and this can't be 9. Because again, this had to be 1, 5, 1, 5, 9, because it could not be 2, 3, or 6. Therefore, the 9 has to be here for the Phistomefel ring. These are different 7s and 8s. So this is a distinctly different 7 and 8 than this. Oh, I don't want to use those colors. This is distinctly different than this. What else do we have? 9 cannot be here or here. Where is the 9 in row 8? It has to be here. So this is 9. That means we have a 9 in one of these two cells. Specifically, this has to be what? The remaining digits in row or column 1 are 1, 2, 3, 4, 6, and 9. Obviously, this can't be 6 or 9. This can't be 3. Where is the 7 in box 1? It must be one of these two digits because it cannot be here because of the 7 here. It can't be here because of the cage. So one of these two is a 7. Therefore, this can't be 7. This is 8, which forces that to be a 7 here. Because it's a different digit, therefore these can't be 7. We have a 3, 6 pair in row 2, which eliminates 3 and 6 in the rest of the row. This must be 7. This can't be 7 here. These can't be 7. Where is the 7 in box 3? It has to be here, so that's 7, which means this can't be 7 here. So we need to have a 7 in one of these two cells here. This can't be 7 because of the 7 here. These can't be 8, so it's a 4, 7 pair in column 2, which eliminates 4 and 7 in the rest of the column and the rest of the box. So this can't be 4. This can't be 4. This is 8. This has to be the remaining digits in row 9 are 1, 2, 4, 5, 8. This can't be 8. This can't be... well, yeah, this is... okay. This can't be 6. Where is the 3 in row 1? Can't be all the filled in digits. Can't be any of these cells because of the 3, 6 pair in that box. So this must be a 3. Therefore, this can't be 3, this can't be 3, and these can't be 3 here. This is 4 or 6. The rest of row 3 cannot contain 4 or 6 because of the 4, 6 pair here. So this can't be 4 or 6. 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 We have a 3, 5, 8 triplet in row 3 also, which eliminates 3 and 5 in the rest of the row. So this can't be 3 or 5. This can't be 3 or 5. This cage cannot contain a 3. So it cannot be 1, 2, 3, 4. It must be 1, 2, 6. So this is a 6, which makes this a 4. This can't be 6. This can't be 4. We have a 1, 2 pair in column 1, which eliminates 1 and 2 in the rest of the column. This can't be 1 or 2. This is a 3, 6, and 9 triplet, which eliminates 3, 6, and 9 in the rest of the box. This can't be 6. Therefore, it's 1 or 2. We have a 1, 2, 1, 2 pair in column 3 or box 7, which eliminates 1 and 2 in the rest of the box or column. Therefore, this is 4, 5. This 4, 5 must be with a 3 to add up to 9, right? You either have 1, 3, 5 or 2, 3, 4. So this must be a 3 here, which eliminates 3 here. This 3, 5, 8 triplet eliminates 3, 5, and 8 in the rest of the box. So this can't be 5. This is 4. This is 5. This 4 eliminates 4 here or here. We need another 1, 2, and 6. This can't be... How did we eliminate... Oh, how did we eliminate 6 here? Oh, because that can't be 1 or 2. So therefore, 6 would require 1, 2, 1, 2. Therefore, the other 1, 2, 6 has to be here. So this is 1, 2, and 6 specifically. 4 cannot be here. 7 is one of these two, but we already knew that. This is a 1, 2, 6 triplet in row 7, which eliminates 1, 2, and 6 in the rest of the row. This can't be 6. This can't be 1, 2, or 6. It's 4, 5, or 7. Can't be 4. We have a 5, 7, 5, 7 pair. So one of these is 6, which means this can't be 6. We have a 5, 7, 5, 7 pair in row 7, which eliminates 5 and 7 in the rest of the row and the rest of the box. So these can't be 5. This can't be 5. This must be 4, which makes this a 2. 2, 3, and 4 add up to 9. This must be 1, which makes this 2, which makes this 1. So this must be 1, 3, and 5, but 5 cannot be here, so this must be 5 here. And this is 3. Okay. This 4 eliminates 4 here, so this is 5. This can't be 9 because of the 9 in the row. This can't be 3 because of the 3 in the row. This can't be 3 because of the 3 in the row. So this is 8. This is 3. This can't be 3 or 5, so this is 8. This can't be 7 because of the 7 in the column. I don't know why I had a 7 there. That's weird. This is a 5, 7 pair. That's fine. Can you have a 27 cage without an 8? That would be minimum. We already know you can't have a 9 in the cage. So without an 8 either, the maximum would be 3, 4, 7, 6, 5, 4, 3. That would add up to 25. So you have to have an 8 in the cage. So 8 has to be one of these two digits. Can you have it without a 7? That means the max would be 8, 6, 5, 4, 3. 3 and 6 and 4 and 5 add up to 9. So that's 18. Plus 8 is 26. So no, you need a 7 also. So one of these is 7 here. One of these is 8. One of these is 7. This can't be 7 then, which makes this 4, which makes that 7. Therefore, this can't be 7 here. This can't be 7 here. We have a 5, 6 pair in column 8, which eliminates 5 and 6 in the rest of the column. So this can't be 5. This is 7. This is 5. 8 is one of these two, so this can't be 8. So we are guaranteed a 7 and an 8 in this 27 cage. That adds up to 15. it could be, that means the other three digits add up to 12. It could be 156, 246, 345. I think those are the only possibilities, right? Interesting. Okay, we have a 3636, a 5656. That's very interesting. What's the rest of box 6? We have 1, 2, 4, and 7, right? Well, this can't be 4 and it can't be 7 because one of these, this is a 4 and this is a set. One of these two is a 7. That eliminates 4 and 7 the rest of the row. So this is 1 or 2. We have a 1, 2, 1, 2 pair in column 9, which eliminates 1 and 2 in the rest of the column. This 7 eliminates 7 here, so this is 4, which makes that 7. This 1 eliminates 1 here. So one of these two has to be a 1 in this 6 cage. So this cannot be 1. This is 2 or 8. This can't be 5. 7 has to be one of these two digits here. You know, 8's one of these two, but that's not helpful. What can be in the middle? You can't have 7, 8, 9, or 4. So it's 1, 2, 3, 5, and 6, supposedly. Okay. That's interesting. This 2 eliminates 2 here, so this must be 1. This can't be 1 here. This is a 2, 6, 8 triplet. This 1 eliminates 1 here, so that's 2, which makes this 1. This can no longer be a 2 here in this row. This is a 2, 6, 8 triplet. This 1 eliminates 1 here, so this is 2, which makes this 1. Okay. The rest of row 4 has to be 6 and 9. And 2 or 4. This can't be 9, though, because we know this can't be 9. So this can't be 2. So this is 2, 4, 6. It cannot be 8. 8 has to be here. The rest of row 6 is 3, 5, 6, or 9. And 5 cannot be here. One of these is a 7. This 3 eliminates 3 here, so this is 6, which makes this 3. So this can't be 3 here. This can't be 3 or 6. This has to be 5 or 9. So 3 has to be one of these two digits here. The rest of row 5 has to be 1, 3, 5, 6, and 7. Well, this can't be 3 or 6. This can't be 1. Okay. So again, we have 7 and 8 in this cross. Okay, obviously this can't be 8. We have 7 and 8 in this cross. The other three digits add up to 12. You have to have 2 digits out of 1, 3, 5, and 6. Therefore, you cannot have 2, 4, 6 adding up to 12. It's 1, 5, 6. 2, 4, 6 is no longer valid, or it's 3, 4, 5. So this cannot be 2 here. Where is the 2 in box 5? It has to be here. So this is 2, which means this can't be 2. This is 6, which makes this 2. That makes this not 2. This is 8, so this must be 6. This 6 eliminates 6 here, so this is 5. This can no longer be 5 here. 6 cannot be either of these. 4 has to be one of these two. This can't be 5 or 6. This can't be 5 or 6. That forces this to be a 7, 8 pair here. And this can't be 8 here. This can't be 1, 2, or 4, 1 or 2 because of the 1 and 2 in the column. So this is 4. This can't be 4. So this is 1 or 2 here. This 2 eliminates 2 here, so this is 1, which makes this 2. This can no longer be 1. Well, where can the 1 be in row 5? It can only be here. So this has to be 1, which makes this 1, 5, 6, 7, 8. So this cannot be 3. This is 6. This was 1, 5, 6, 7, 8 to add up to 27. This can't be 5 then. This is 9. This is 3. This is 4. This can't be 5 because of the 5, 7 pair in the row. So this is 6, which makes this 5. This 6 eliminates 6 here, so it's 3. This can't be 3 or 9. This is 6, which makes this 9. This 5 eliminates 5 here, so this is 7. This is 5. 7 eliminates 7 here, so it's 8 and 7. That leaves this as 3, 4, and 9. This must... No, that's not right. 4, 8, and 9. This can't be 4 or 9, so this is 8. This can't be 8 or 9, so this is 4, which makes this a 9. And that's how you solve it. Very cool, actually. Very nice use of the Phistomefel ring theory along with these cages, which you had kind of major restrictions there. That was very cool. Very, very nice. And that was fixed with this row. That was just very well set up. A very, very cool, essentially first break-in. Yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.